Alright, so we're expected to check if this particular equation is dimensionally consistent. Now, for an equation to be dimensionally consistent or dimensionally correct, all the terms present in the equation should have the same dimension. That implies that for this particular equation to be dimensionally consistent, v, which is one term, and the entire sine at squared divided by s is another term. These two guys should have the same dimension. So let's see if they have the same dimension for us to know if it is dimensionally consistent. Let's start with the right hand side. We have sine at squared over s. Now our a is acceleration, our t is time, and our s is displacement. For trigonometric functions, the argument, when we say argument, that is what is inside of the trigonometric function, more or less like the angle of that trigonometric function, should have a dimension of 1. So that means that if I solve this completely in terms of their dimension, the solution should be equal to 1. So let's see. Acceleration, the base unit is meter per second square. So that means that the dimensions will be L over t squared. Time, this is t squared. Time is measured in seconds, so time squared will be what? Second squared, while the dimension will be t squared. The same thing, displacement is s. S is measured in meter, that's the base unit, while the dimensions is L. So that means that at squared over s will be, what's our a in terms of dimension? L over t squared times, what's our t squared? T squared divided by, what's our s? L. T squared cancels t squared, we have L over L, and that is 1. So that means that the dimension here is 1. This v here is velocity. What is velocity? The base unit is meter per seconds. That means the dimensions is L over t. So that means that this part is L over t. So can we say this equation is dimensionally consistent? No, it is not. You can just say this is actually nonsense. This equation does not exist because the terms in the equation do not have the same dimension. So this is not this particular equation is not a correct equation.